Okay, so a 2 kilogram bucket is tied to a rope and accelerated upward out of a well at the rate of 1.5 meters per second squared. Neglect air resistance, that's important. And then diagram the forces acting on the bucket. Yeah, first thing, gravity. We always have gravity. And because it tells us there is a rope, that tells us there's tension, it's accelerating upward. So we know that we need to have a larger force in the upward direction. Tension force. Okay. So, what is the sum of the forces in the x direction? 0. There are no forces. Make sure you include a unit. 0 what? Newtons. And then what's our acceleration?
0.
In the x direction.
0.
It's also going to be 0 in the x direction. Okay. Now, we need the sum of the forces in the y direction. Now, this comes straight from Newton's second law. Regardless of what forces are acting on the system, we know that the sum of the forces will be equal to mass times the acceleration in the y direction. It tells us the acceleration in the y direction. What is it? So 1.5. So you already know this answer, 1.5 meters per second squared. And does it give us the mass? Yes, it does. We have this 2 kilograms. So it's just 2 times 1.5, which is 3 newtons. Okay. So it comes from the question that 2.0 kilograms. This is a 2 kilogram bucket. That's our mass. No, air resistance is its own force. It's a contact force between you and the air around you, because air is particles. So it doesn't feel like we're moving through anything, but we're really slamming into all of those air particles that are around us. And so there's that frictional force and air resistance there. So it's just saying if we had air resistance, because we were moving up, there would be another force acting down. But we don't have that, so we're just ignoring it.
So when it says
most of the time it'll say neglect. Rule of thumb, friction and air resistance should be ignored unless it says it's there. Okay? So always assume it's not there until it says, by the way, there's friction here.
If there was air resistance,
Okay.
force would be present.
If there was air resistance for this problem, we would have to include it on the free body diagram, but overall this answer would not change. If we're still accelerating at 1.5 meters per second, we still have a 2 kilogram bucket. The sum of the forces in the y direction is just mass times that acceleration in the y. Now, they could take it a step further and say, what's the tension force? What's the force of gravity? They could go and ask that, but they don't. They just ask, what's the sum? What's the net force? And that's just as simple as 2 times 1.5.